Welcome to the second installment of Smarter Circuits. I'm your host, Ian Klein, and in this video we're going to set up the Shelly 1PM and Shelly 2.5 relays for cloudless home automation using Mqtt and Python on a Raspberry Pi. I'll skip the history lesson on relays I started to accidentally write. Suffice it to say, today's video is brought to you by the process of converting these into these, and sometimes these. There will be more videos about these relays that cover other uses and more complex controls and programming, but even in those cases, this video covers most of the initial configuration and basic information you'll need. What we'll be doing is creating an end-to-end smart circuit, that is, a circuit we can control remotely and write conditional logic for. This is useful for many reasons I won't list, because being here means you probably already at least have one in mind already. I want to show you how to use these, but I don't want to tell you how to use them, meaning I want to show you a basic fundamental application without limiting your own creativity. Before we get started, I just want to go over what we'll be doing at a high level. In the video, we're going to do the following: wire up a Shelly Wi-Fi relay to a circuit and test both, configure the relay's Wi-Fi and connect it to an Mqtt server we'll install on a Raspberry Pi. We'll build a lightweight API in Python using Flask that will publish messages to the Mqtt server. We'll build a simple button interface in Python for use with a touchscreen. And we'll build a local web-based single-page application in Angular where we can control and view information on our system. I will not be going over voice recognition or Home Assistant integration in this video, as there is already a lot of ground to cover. Also, I won't be using authentication in this example, mostly to avoid clouding the content, but also because there will be future videos on this topic and it's worth focusing on solely. So, in case it needs to be said more plainly, the API and web interface we're going to build is not meant for a production or publicly accessible environment. Local use is probably pretty safe, at least as safe as your Wi-Fi itself is, but even the local-only systems that are live in the house have various authentication and security protocols in place. Let's begin. You remember these from the first video, right? No? You didn't watch the first video all the way through? Yeah, me either. This is a Shelly 1PM Wi-Fi relay. The PM stands for power meter, or metering. There are a few versions of the Shelly 1 available, one without power metering, but why not just have it, and one that doesn't require a neutral wire, although this is not a concern of mine, so I've never used one. Wiring is very straightforward, as the devices are very clearly marked and come with very simple, easy-to-read instructions. You'll run your neutral or white wire to the terminal marked N for neutral, and to the neutral side of your outlet or fixture. Then you connect the hot or black wire from the mains to the L1 terminal on the Shelly 1 or the two L terminals on the Shelly 2.5. If you're using a switch, toggle or momentary, you will connect it between the mains hot and the SW terminal on the Shelly 1. On the Shelly 2.5, you'll connect each switch between the mains hot and the SW1 and SW2 terminals for outputs 1 and 2 respectively. There is a different way to connect the Shelly 2.5 for use with actual roller shutters, but we're not talking about that in this video. You do not have to connect a switch to these relays, and I don't in my system because I don't need to. I also want to point out to those viewers who may be following this series to update their old low-voltage systems, do not use your original momentary switches for these relays. It might work, and it might not be terribly unsafe in many cases, but I would not recommend it given the age of these switches, as well as the possibility that the wires or switches themselves are not rated for the 120-volt power, and they are not protected from overcurrent in any way. There are ways of integrating another relay in order to use these, and that's actually the next video, but it's more complicated and perhaps marginally overkill. We'll see. At any rate, the last connection you need to make is the output, marked as O on the Shelly 1 and O1 and O2 on the 2.5 for the first and second outputs respectively. That's it. The relay is now ready to be powered on and configured. When I set up the relays on my system, I used my phone for this next step, but I'm using the computer for this video because it's just easier to see everything. Once you've powered on your relay, you'll be able to connect to its ad hoc Wi-Fi, which will be named Shelly, the model, and the MAC address, which you don't have to know ahead of time, but if you're setting more than one of these up, just power one up at a time and at least configure their Wi-Fi before powering on the next to avoid confusion. This should go without saying, but things that go without saying usually don't end up going without saying, so I'm saying it so it goes. Now that we're connected to the Shelly Relays Wi-Fi, we just navigate to 192.168.33.1 and we get this really nicely styled dark mode looking interface. This is one of my favorite things about all Shelly devices. They really did a fantastic job on the interface, and not just on the surface. There's a lot of configuration capability here. I have some minor pedantic complaints, but this vastly outdoes any other devices I've used, and most of those aren't even device-hosted interfaces. Okay, I'll stay on point. Clicking on Internet and Security, we see the following. All of Shelly's devices have this same section with a few differences per device purpose. We can expand Wi-Fi mode client, tick the box next to connect the Shelly device to an existing Wi-Fi network, and fill in our details. Some of the devices I've purchased didn't initially have the static IP option, but it became available after a quick firmware update, and I highly recommend it. After entering your Wi-Fi credentials and desired IP configuration, just hit Save, switch back to your Wi-Fi network, wait a minute or two for the Shelly to connect to the network, and then navigate to the IP you assigned. If you didn't assign an IP, you'll probably have to log into your Wi-Fi router to see what address is assigned by DHCP or use a scanning tool like Fing. At this point, I usually set the login to the device itself for security. This is found under Restrict Login. After saving that, you can log back in, but we're going to put this aside for a little bit and come back to it. It's time to get our Mqtt server ready. A quick rundown of what Mqtt is. Mqtt stands for Message Queuing Telemetry Transport, which, put plainly, just means it's a protocol for holding and relaying simple messages organized by topics between publishers and subscribers. The important functional feature of this protocol is the server's ability to notify subscribers when a message has been published to a topic. Now, when I say publishers and subscribers in this context, I am referring to applications. For this example, our subscribers are the relays and our publisher will be the API we'll get into in a little while. Each relay will subscribe to a topic specific to its own identifier, a combination of model and MAC address similar to the ad hoc network ID from earlier. The relay will also publish messages to these topics and subtopics about itself, including power, state, current, temperature, and exact voltage if you've done the latest firmware update. Similarly, the various sensors Shelly makes report their readings this way, although there is some inconsistency in data formatting that I'll go over in the appropriate video. The relays will tell you if they are over temperature, and you can even lower the internal overcurrent protection. Other devices report battery status and other conditions you can make good use of to notify you when something needs attention. Installing and starting the Mqtt server is probably the easiest thing we'll do in this entire video series. There is, of course, a variety of things you can configure for more security or logging, but we're keeping it pretty basic for this video. I'm not going to go over the entire process of installing an image on your Raspberry Pi or enabling SSH and all of that. I will provide links to this information in the description, but for time's sake, I'll assume your Pi is set up, updated, and ready to go. SSH into your Pi, or open a terminal on it, you know the drill. Use sudo apt install mosquito with 2 T's to install mosquito with 2 T's. Although it isn't absolutely necessary, we're going to set up a username and password for the relays to subscribe and publish with. To do this, just create a text file, I use Nano to do this sort of thing, and put in the username and password separated by a colon. Use the following command and the name of the file you just created to encrypt it. Now we copy the file into the Mosquito directory and open the configuration file. Set the password file location. You can turn off anonymous connections here as well, but I'm just going to leave it on to make the API connection a little simpler later, and that's pretty much it. There are other things you can configure later, as I said, but this is all you really need. A useful tool you may want to grab is Mqtt Explorer. I use both the Windows and Linux versions. Let's get back to our relay configuration. Log in if you're not still on the page and expand the Advanced Developer Settings section. Fill in your username, password, and IP address and hit Save. Now, if you have Mqtt Explorer, you can log into the server and you'll start to see messages from your relay. You can send a message to your relay as well. You send on to Shelly's /your_relay_ID/relay/0 or 1 if you have a 2.5 and want to control the second circuit /command, and it will turn the circuit on. To turn it off, send off instead. Easy. I'm sure you're starting to see where all of this is going. Now let's build a simple API. I'm going to do this all in Nano because it's tedious and convenient all at the same time. Begin by creating a file called api.py. Then import your Flask API library and your Paho Mqtt client library. Then we'll instantiate our API and then start our program. Next, we'll run the API with debug on. We'll run it on port 8080, and we'll give it the local IP address as the host. Next, we'll create a route. We'll call it control and give it a text parameter. Create the method with the text argument. Let's convert the command to lowercase, and now we need to know whether we're turning it on or off. This may not be the best way to do this, but this is the way that I like to do it. We'll check for on in the command, and then set the state to on. And we'll add a space here. Probably aren't too many circuits that start with on. And now we'll create a dictionary to store our circuits. This way we can add more later. We'll give them the address. And then we'll want to store the relay. 0 is the first relay and the only relay on the Shelly 1. Now we'll iterate through our keys. Grab the circuit configuration. Again, making everything lowercase. Replace the underscore with space. Check if it's in the command. And construct our topic. We'll give it the address. And then, of course, the relay. Finally, command. And now we'll create a list of commands so that we can control more than one circuit at a time. We'll give it a topic and the state. And now we need to send these commands. So we'll iterate through our list. And then we'll create a new method for publishing the message. We'll give it the topic and message. We'll put this in a try except so that errors don't stop the program. We'll create our client and then connect it to our Mqtt server. Then publish the message to the topic. Now disconnect from the client, and then we'll write our accept. Now this is not proper error handling, it's just what we're doing here. Now we'll go down here and we'll use our new method. Send the topic, that's the topic, and the state. There's a note about this return in the description. This was not the proper way to do this. It needs to be an object. Now we'll start the API. And it is listening on port 8080. Our API isn't running as a service right now, which you are going to want to change, but I'm not going to cover that in this video. I'll include a link on one way to do this in the description, but it's worth doing a bit of reading to find the best method for your purposes. Now, we have endpoints for turning the circuit on and off, but we'll probably want to know more information about the state of the circuit for various reasons. So we'll be coming back to the API after we write the monitor program in order to add that functionality for the two interfaces we'll finally build towards the end. I am recording this after shooting and editing this episode, but before you started watching it, unless you're watching this before I recorded either, in which case I commend you on your bravery and fine work. Due to the unintended length of the original episode, it has been divided into 3 parts. The second and third parts will be linked in the description once they are available, which will be next week and the following. Part 2 of this episode will cover building the monitor service and touchscreen interface and will be available next week. I do hope you enjoyed this first part of Smarter Circuits' 3-part episode on Shelly relays and home automation using the Raspberry Pi, and of course, if you did enjoy it and haven't done so already, please do subscribe to the channel. If you want to know what's going on between episodes, you can follow Smarter Circuits on Twitter @CircuitsSmarter, and if you'd like to help make more and better videos possible, consider becoming a patron on our Patreon page linked below. Thanks for listening to me ramble, and I do hope you'll join me for part 2 as we continue building smarter circuits.